Hi, my name is Alessandro Gangelosi and that's a new tutorial coming from cgcookie.com for MaxCookie. This time we'll be back to talk about Dreamscape plugin, and in some past tutorial we talked about the general information on how we can use Dreamscape to create an ocean scene and how to tune the parameters, also to obtain the foam over the sea. And this time we'll talk about the dynamics and the object dynamics and the foam generated by the object dynamics. So you see I'm working inside 3ds Max 2010, but obviously you can use all the other version. The important thing is to have Dreamscape installed. So let's go there inside the objects, and we can go in the Dreamscape objects, and we have the sea surface, and we can create a really simple sea surface there. Let's remove the grid using the G key in all the viewport, just to have a better quality in the visualization. And you see that's our starting mesh. Let's try to have it bigger, so we can use, for example, 1750 and 1750, and you see that's our mesh. Let's go there and let's say that we like to see the edges, and we can try to have 64 by 64 to have a better quality, and we can have a better detail, and you see that is really fast, so we can move just a little bit more, and it's again fast. Let's go inside the waves parameters, and we can change the choppy waves to have more realistic waves over the sea, and you see that's not bad. We can move it more and more. Let's remove the edges faces now, just to see if we have problem with the face. Just a little bit. Okay, so you see that's our actual result. Obviously then rendering we can have some problems, so we have to change just a little bit. Okay, that's our sea mesh, and let's try to have just a little bit more speed to have higher waves. Okay, so you see that's our basic sea setup. Let's rotate the view, and that's our basic scene. Okay, then we can for example create a sphere. That's our mesh actually. Then we can go there, and you see that there we have inside the helpers the Dreamscape daemons, and we have the simple waves that can be used to work to create more waves inside the sea, and we have dynamics. Let's go there. We can create the dynamics, and you see the dynamics must be big as the sea mesh, because we have to understand where we have the dynamics, and we can add the object inside the simulation. Let's add the sphere, and for the moment we can stay with these parameters, it's not a problem. Let's go there inside the sea surface, and you see that on the last part of the parameters we have the Dreamscape daemons, and we can set to on or not, and we can select. Okay, so that's our dynamics, and now we can go. You see we have everything ready. Let's go there, and that's our mesh. Let's select the sphere, and we can give some maps just to be sure we see the rotation and the movement. So let's go there and let's use the checker. Let's make it visible, and we say we need more tiling. Okay, Then let's go back there, and if we go there, we see that we have the export parameters for the dynamics and the foam. Let's say that we like to see an update every 5 frames. Calculate, and you see that the dynamics is starting, and every 5 frames we have the update there in the viewport. But as you can see, we have no movement there for the sphere, so that's something we have to do before. So let's close this one, and you see that there we have objects in simulation, and then we have physical properties, and we have the possibility to say that this object is unyielding, so it's not moving, or we can say to use the dynamics. So for example, if we have a bigger object there, and we like that the water will collide over this mesh, we can do it. We have just to say that the object is unyielding, or if we have an animation or something like that, and we can say use dynamics, and we have, you see, some parameters as the mass, the friction, and the inertial forces, and we have the possibility also to add forces there. And we can go back there, and we can say calculate, and you see that we have no more the sphere, so something is happening to the sphere. So let's close, let's go there, and let's try to understand. You see that the object is going away, and maybe the problem is the mass. Let's try to have a little mass for this object. Let's say calculate, and you see that the object is going away again. Let's go there, and let's try to use again a really low mass, and again. So let's try to understand what's happening to the mesh. I just moved the mesh there, and we can remove all the keys, and we'll try to use the mesh out of the sea, and let's try to understand the proportion for the scene. So let's go in customize, unit setup, we have centimeters, and then let's go back there, and let's figure the measure of our mass, and let's say that we have 7 meters by 7 meters, and we have to understand the parameters for our scene. Okay, so let's move the sphere near the mesh, and let's go to set some parameters. And talking about the dynamics daemon, the first thing I'd like to say is that we have also to remember that the simulation grid spacing is really important, because it's the quality of the simulation, so the amount of detail we can have. Actually, you see that we have 1.0, and that's a good value because we can have a not so bad simulation, and the speed is really fast. Then we have the grid size, and the grid size is the size of the daemon we are using, and you have to remember that the simulation is calculated inside the daemon border. So if we have the sea that is bigger than the dynamic daemon, you have to imagine that the dynamics will be calculated just inside the daemon. So for example, in this case, if we have a wake created by the sphere impacting to on the water, over the water, the wakes will move going to the border of the dynamic sides during the propagation, and when the wake will collide to the border, will be reflected again inside the water, and that's due because we have just this area for the simulation. It's like we have 4 floor all around, sorry, 4 wall all around our sea actually. So we have to start to work on the other parameters, trying to figure out to obtain a better quality. The first thing I try to do is to have more gravity, so let's try with 90. Then let's move it there, and then we can change the propagation. The propagation of the wake is the speed used by the wake to move through the water surface. So we can try with 15. And the damping is the slow down process to the propagation of the wake. So for the moment we can stay with the basic value 5.0. Let's try to make a calculation, but before I like to have more frames. So let's try with 200, and then we have to go there inside the export parameters and set the end frames to 200. Let's calculate the simulation. You see that it's really fast, and you see that the our objects fly away. You see. Okay, so we have to change some parameters, and the first parameter is the mass. Let's try to have, for example, 5000 for the mass value. Let's calculate again the simulation, and let's see if we have interaction between the water or not. And I can see there the waking. Then when we have more frames we can check it, and you see that the sphere is moving over the surface. Actually we have not so much friction between the sphere and the water, so the water is moving and the sphere is not so moved by the water wakes. Let's stop it, and you see that we have there some interaction. To see more interaction, we have a parameters that is the wake scale. That is really useful, as you can see, to scale the height value for the wakes, so we can see it also when the wakes are not so visible. And later we can decide if we have to use this parameter or not. Let's go to the C parameters, and I like to see no, okay, it's too much. It will be so slow later to be calculated. The water value is the density of the water, so we have differences if we have less density or more density. Let's try to see what happens if we have just 10 for the density. Let's simulate it. Let's wait until the sphere will collide with the water. You see that the sphere is going inside the water, so you have to work with water density and the mass of the sphere, trying to find the best compromise between these two parameters. So for example, now we see that the sphere is going inside the water, and that's not so good. So I'd like to use more density, and we can use also just a little bit more less friction. Let's try with 0.2. Okay, and let's try to have also more wake strength. Let's try with 4, and this parameter will control the amount of wake created by the dynamic interaction between our mesh, and you see that we have higher wakes, so we can change, for example, now the parameters, the value for the wake scale. Let's stop it, because you see that at the beginning it's really high, so we can lower it. Okay, let's try to figure also some differences, and the differences can be produced by have just a little bit more density there and more mass for the objects. So let's try with 10,000. Let's go to calculate to see how it looks. And another thing I'd like to do is to have more polygons over the sea level, so we can see more detail So let's stop it, and you see that's our actual uh, interaction. Let's select this one, modify, and let's go for 120 and 120. Okay, so you see we have more detail of the water interaction. Okay. Um, Another interesting stuff is the possibility to have a mesh that is not moving. So for example, let's create this cylinder. The 8 is really high. Okay. Um, and we can go there inside the dynamics and add also the cylinder. And let's set the cylinder. Let's say that we have an object unyielding, so it is not moving. It's a fixed or and animated objects. Let's see what happens now if we try to calculate the simulation. You see it's just a little bit slower because we are using more mesh. But we'll see also how the wakes generated by the sphere inside the water will interact with this cylinder. And you see that we have the interaction with a reflected wakes. So the wakes that go through the cylinder will be reflected, and it is coming back to the sphere. Okay, let's stop it. And you see that's the result, and you see the dynamics. Okay. Let's go again back there, and let's try to have more polygons again, 200 and 200 segments. So we have a lot of detail over the water, and you see what happens when the water is flowing down and moving. Okay, let's save our scene in the right folder. Sorry, and tutorials 200 February 2004. Okay, so let's call it 4. Okay, and we have the scene saved. Now I'd like to go back inside the dynamics, and we can start to play just a little bit with the scene. So let's go there inside the light. Let's use the Dreamscape light, sun, and let's go there. Okay, we have the sunlight. Let's go there inside the environment, and let's scale it. Okay. Okay, geometry and geometry. Okay, perfect. So we have also the shadows. Let's go there, and let's say that we like to use the Dreamscape. So let's remove the cloud, because it's not important actually to have the cloud inside the scene. Let's render just a test. So that's our test, and I like to say to use the render daylight. So we'll have some kind of global illumination simulation, you see, just using the sunlight coming from the Dreamscape. We can maybe speed up using a lower sample rate. Let's see if it is faster. And you see we have just a little bit of grain, but it's good for our test purpose. And then let's go there to see if we have the sky inside. Okay, we see the sky, and we can start to use the right value and parameters for the sea. So let's close this one, and let's select the C mesh. Let's open the material editor, and there we can call it Ocean Shader, and let's use the Dreamscape C material. We can assign it. Let's make another test render, and you see that that's the basic C actually. So let's move this one to have a bigger mesh inside. Okay, so that's our test. Okay, we have to change just a little bit, and we can say that we like to apply the shadows over the glittering, and then we have the sky color. We can use the Dreamscape sky. Let's see how it changes. And you see we have a different coloration for the sea, and we have the self-reflect and self-reflect. And let's render just a region, and you see that it is changing actually. Then let's go there and let's add, first of all, let's change to real earth, so we have a better simulation for the sky. Okay, and then let's go there and let's add also the Dreamscape subsurface. Let's use the actual parameters, but before we have to go inside the material editor, and let's say that the underwater color is the Dreamscape subsurface. Let's render a test, and you see that's the render. So actually it is simulating the scattering just using this value. So for example, we can say that the sea level is 120 centimeters, and you see that it is changing based on the height for the water. Or we can go back to 25, and we can say maybe that the density is just 2, and let's render, and you see that we have a really high subsurface scattering. Let's try with 20, so the double parameters we used before, and you see that we have a lot of density inside the water, but this model is not so accurate, so it's better to go there for the physical one. And let's render, and that's our physically based. So we can go there and we can say that the water is 120 centimeters. Okay, and the density is 10. And let's move it there to see also how it works with the underwater mesh, and you see that we have the scattering there. We'll say okay, we can use obviously less turbidity under the water. Okay, just a little bit, so you see we have more blue, or we can use also the self-defined scattering color, and you see how it is changing. So let's go back to the other stuffs, and we can see how it looks. Okay, we need to save, and then we can go there. Okay, and let's add again the simulation. just some frames just to see how it looks inside the renderer. Okay, let's stop it and let's go, for example, there, and let's open this one. Okay, and we can render this area. And you see that this one looks really realistic, and we can use higher value. And let's move just a little bit there. Okay, let's go back, and you see that we have higher value for the wakes. Okay, let's save. Okay, now we can work just a little bit on the foam to see how it looks. And let's go there, and we have the possibility to control some properties for the foam, and we have the maximum, so that's the maximum amount of foam, and there will be no more foam over this value. The persistent is the amount of frames that the foam need to disappear, so actually we have 20, and the spread is the spreading all over the surface of the water, and actually we are using 1, and 1 means that the foam will spread all around in the same way. Then we have the possibility to have the foam generated by the wakes and the foam generated by the object's impacts shown in viewport, so we can see it during the calculation. And let's start to calculate it, but we have to say where we'd like to save this map, and I try to use it there. Form new, okay, and let's calculate it. And you see that there we have the map for the form that will be calculated. And let's check when the impact will happen, and you see that we have the form calculated there, and you see that the form is the white area over the water that we can see now. Obviously, if we have an object moving as a boat or something like that, we can use the foam from objects. So the foam will be generated by the object's interaction with the water. So you see that the foam is expanding all over the mesh. And I'd like to change some value. So let's say that we have, let's go there, 10 frames for the persistence, and we have, let's try 15 for the creation. So let's try to calculate it again. Let's move there the map so we can see how it looks. And you see that we have just a little bit less foam density over there. You see that it is changing faster. So you see it will be not so persistent as before. Let's wait. Let's try to simulate all the frames. also because we have no more weights over the surface, so it's not so good to have a huge amount of foam when we have no more weights. Obviously we have just a little bit of foam because there's interaction between the water and the sphere, so we continue to have just a little bit of foam there. Let's wait for the other frames we need. Okay, let's check it, and you see that we have this foam over the surface. Obviously you can change the parameters in any way to find your better and best setup. Okay, so let's go there inside the material, and let's say that we are using a foam map, and let's use the Dreamscape C foam. Let's try to render, and you see that we have nothing over the water surface. So let's go there, and let's say that we have the foam, and let's say that we like to use the exported foam, and you see that now we have a foam. We can say too much foam because it's really so white, so we can go there and we can say that the low density is black, for example, and let's see how it looks. Just an area, for example this one. Okay, and then we can work on the visibility, so let's change to 0.5 for the moment. Let's go to 0.6. Is not so complete this foam simulation, obviously, because I'm not working on a complex shader, but you can use nested procedurals with the maps we have actually to find a better look for the water. So you see that now we have the foam there. Let's go there and let's see. For example, there we can decide to have, for example, let's try with a smoke. Let's wait. We have to tune the parameters. Oh, sorry. And let's go there. Let's try to change this one. Let's try with 5, and maybe it's 0.2. And let's try to render some frames before, so it will be faster. And let's render. And you see that we have it. Obviously the quality is not so good, but we can go there and we can say 1, and we can try to have it more little. So we have some more complex stuffs there inside the foam. Okay, let's try to see some frames later. Obviously you can create a more complex shader. We can see maybe in a future tutorial how to create a more complex foam shader to obtain a better quality. For example, if I use an inverted map there, you'll see that we have it's really so not so much visible, but we can use, for example, 5 10. Okay, and let's try to have more visibility like that and more interaction, and we'll see something different there. So you see it's not the maximum quality, but it can be not so bad, and we can, for example, mix this one, keep all map, and then we can use, for example, cellular. Use 100% this one. Let's see how it looks, just to find a really fast way. Okay, you see this one, and we can use this one more little, something like 2. Let's try to invert the image. Okay, something like that, and we'll try to mix 50%. It's not the best way, but it's just to see what happened on the water when we try to mix some stuffs. Okay, you see we have different parameters, but we can try to do something like that, so we have less interaction between the two maps we are using, and that's a best result, better than before. Okay, let's save, and we can set the rendering size to 900 400. Okay, and let's say that we like to show the save frame, and we can move just a little bit near there, and we can render the entire view, and we'll have our final render. If you like, try to play with the full map, just trying to find a better look for our foam. We can see, for example, how it looks there. And as I said to you before, in a coming tutorial we'll work on some other shader, trying to figure how we can obtain a good foam interaction. Okay, so for this tutorial that's all, and we'll work more on Dreamscape for self-dynamics interaction with self-moving objects in the future. Thanks, bye.